Next problem. The autocorrelation function for a stationary process x of t is given by Rx of tau is equal to 9 plus 2 e power minus lambda tau. Find the mean and variance of the random variable y, which is equal to integral 0 to 2 x of t dt, and the variance of x of t. Given r of tau, which is equal to 9 plus 2 e power minus modulus tau. That is equation number 1. We know from the property expected value of x of t is equal to root of limit tau tends to infinity r of tau. So we know the r of tau is given 9 plus 2 e power minus modulus tau. Replacing, we will get root of limit tau tends to infinity 9 plus 2 e power minus lambda tau. As the limit tau tends to infinite, so e power minus infinite is 0, so you will get root 9, that is equal to 3. So mean, which is nothing but 3, that is equation number 2. We know variance, which is equal to expected value of x square minus expected value of x the whole square. Now need to find expected value of x square. From the property we know r of 0. So replace tau by 0 in r, equation number 1, we will get 9 plus 2 e power minus 0, that is 9, plus 2 into 1, that is equal to 11. So expected value of x square is equal to 11. Therefore variance, which is equal to, so 11 minus expected value of x the whole square, that is 3 square, that is 11 minus 9, right, that is equal to 2. So we find next we need to find that mean of y, right? Expected value of y, which is equal to expected value of y is given by 0 to integral 0 to 2 x of t dt, right, by the equation, right, integral. So we, without loss of generality, we are exchanging the integral and expectation, and we are taking inside the integral. So integral 0 to 2 expected value of x of t dt. So expected value of x of t 3. So replace. So we get 3 integral 0 to 2 dt. So integrating dt, you will get t, lower limit 0, upper limit 3. So 3 minus 0, 3. So 3 into 0 to 2, 2 minus 0, so you will get 2. So 3 into 2, you will get 6. Next to find the variance of y. Variance, we know x bar mean, which is equal to 1 by t integral 0 to t x of t dt. And that is equal to 1 by 2 integral 0 to 2 x of t dt. But integral 0 to 2 x of t dt is nothing but y. So 1 by 2 y, right? So next x bar t is y by 2, therefore y is equal to 2 x bar of t, that is mean, right? Now variance of y, which is equal to variance of 2 x bar, right, x bar of t, that is equal to variance of ax is nothing but a square into variance of x. So same formula, so 2 square we will get 4 variance of x bar t. So variance of x is equal to 4 into variance of x bar t. We know that variance of x bar t, which is equal to, from the formula, 1 by t integral minus t to plus t 1 minus modulus tau by t covariance of tau dt. So variance of x of t is equal to 1 by 2 integral minus 2 to plus 2, right, 1 minus modulus tau by 2 cxx of tau. Now we need to find cxx of tau, that is equal to rxx of tau minus expected value of x of t1 into expected value of x of t2. So by using 1 and 2, we will get 9 plus 2 e power minus tau, modulus tau minus 3 into 3, right, that is equal to 9 plus 2 e power minus tau minus 9, so you will get 2 e power minus modulus tau. So cxx of tau is nothing but 2 into e power minus modulus tau. So from equation 6 and 7, we will get variance of x of t, which is equal to 1 by 2 minus 2 to plus 2, 1 minus modulus tau by 2 cxx of tau, that is equal to 1 by 2 integral minus 2 to plus 2, 1 minus mod tau by 2. So replacing the value of cxx of t, 2 into e power minus modulus tau d tau. So we are taking 2 outside, so 2 by 2 integral minus 2 to plus 2 e power minus tau d tau minus splitting the integral, right? First term 1, so 1 into e power minus tau dt, first integral. Second integral we will get minus, so minus there is tau by 2, so taking 1 by 2 outside, 1 by 2 integral minus 2 to plus tau modulus tau e power minus tau d tau. So we are splitting the integral minus 2 to 0 e power minus tau of minus tau plus into dt plus 0 to 2 e power minus tau dt, because modulus tau value, so when modulus tau is equal to minus tau, tau is less than 0, so limit is less than 0, minus 2 to 0. If tau equal to tau, tau is greater than 0, so limit is positive, that is why 0 to 2. We are splitting the integral according to that. Similarly for the second one, minus 1 by 2 integral minus 2 to 0 minus tau e power minus tau dt minus 1 by 2 integral 0 to 2 tau e power minus tau dt. Now we are integrating e power tau, right? E power tau integral e power x only. So lower limit and upper limit minus 2 to 0. Similarly minus e power minus tau, e power minus x is nothing but minus e power minus x integrating, right? 0 to 2 limit. Then plus 1 by 2, next tau e power tau minus e power tau. So x e power x is nothing but we are using uv formula, right? Integral u dv is equal to uv minus integral v du, right? So from that we will get tau e power tau minus e power tau, lower limit minus 0, minus 2 plus upper limit 0. Next, similarly the next one, minus 1 by 2 minus tau e power minus tau plus e power minus tau 0 to 2, right? So applying the limits, e power 0 minus e power minus 2 plus minus e power minus 2 plus e power minus 0 plus 1 by 2 0 minus e power 0. First lower limit minus the upper limit, minus 2 e power minus 2 minus e power minus 2 minus 1 by 2 minus 2 e power minus 2 plus e power minus 2 minus 0 plus e power minus 0. So grouping all those things, so we will get 2 plus 1 by 2 minus 1 by 2 minus 2 e power minus 2, 2 e power minus 2 plus 1 by 2 e power minus 2 minus e power minus 2. So 1 by 2 minus 1 by 2 cancel, minus 2 e power minus 2 plus 2 e power minus 2 get cancelled. Half e power minus 2 minus half e power minus 2 get cancelled. So balance remaining you will get 2 only. So variance of x of t is equal to 2. So from 1 we are getting variance of y is equal to 4 into variance of x of t, that is equal to 4 into 2, that is equal to 8. That's next we will see.